Going to talk about handling conditional statements in Swift. As in life, where we make decisions all the time, like in the morning, you get up or don't get up. Is it time to get up? If it is time to get up, then you get up, else you still stay in the bed. And then there are a lot more conditions sometimes. There are conditions like if X happens, then I'm going to do something. If Y happens, I'm going to do something. If Z happens, then I'm going to do something totally different. So there can be multiple conditional blocks in real life. Similarly, there are loops that go on. Is my coffee warm? If my coffee is now warm, I'm going to take it up and I'm going to drink it. If it's not warm, I'm going to wait and I'm going to let it keep getting warm. So there are loops that we have to go through. And now we're going to cover those in Swift and see what's the syntax for handling conditional statement and loops in Swift. We are going to start with simple if-else conditions. And as you can see in the screen, I've started with a very simple example of stock index. And let's say the stock index is hypothetically 3,213. I simply go forward and make a check saying that if my stock index is greater than 3,000, then all is good and I'm in a bull market. So if my stock index is greater than equal to 3,000, then I'm in the bull market. Otherwise, I am in the bear market. So it's a very simple if else conditions, but the point is that I'm trying to emphasize is that these conditions are very similar in written nature when you compare to other programming languages. There is a catch though. The way I have written this in syntax, and let me make sure it's configured to automatically run, which it is. So this one, the way it's written is more C style, which you see that I put the if condition, I started the brackets, after in the bracket I put a condition check, and I'm done. But in Swift, the Swifty way is that unless the brackets add clarity, which is there are multiple if conditions that are being grouped together, and a bunch of times that will happen prime because there's not a single if condition. You're using logical operators that we'll see, then you put brackets, otherwise you just drop the brackets. Again, Swift is all about being concise. So if unless something adds value, you just don't add it. Here brackets were not adding any value, so you didn't add them. And we can still go forward and we can still execute our program, and I'm gonna execute it again. So I can still go forward and execute my program, and I can see that my stock index was greater than 3,000 and we're in the bull market. And that's the Swifty way of doing the things. If my stock index drops down to, let's say, 2,789, now I am no longer in the bull market. I am now in the bear market, as you can see on the screen. The other item to note here is that unlike the legacy C, C++, and Java languages, um, in Swift, the if condition must evaluate to be a Boolean. That is, it cannot be a number. And in a lot of other languages, what used to happen is that you would put anything which is zero is considered as false, anything which is not zero is considered true. So if a number is 2,789, it's considered true. That's not true for Swift. Swift, the if condition must evaluate to be a Boolean condition for it to actually work. So simple if else, you put in the condition, drop the brackets if there's only one condition, and you can go forward and have condition statements in your code. Now let's look at another variation of if else, which is called as optional binding. Earlier in our lectures, we talked about optionals and the fact that in option with question mark, I can specify to Swift that this variable may or may not have a value. And there's a separate video for it if you have not covered. But in Swift, everything is supposed to be not nil unless it's of type optional. Now I have gone forward and defined an optional string, option integer here, as you can see. And then I'm going forward and assign it some value. Again, I'm going with the stock index example. So it's 3,213. Now I go forward and make a check saying that, okay, if my current index, if my stock index is above a certain value, then I'm the bull market. The catch here is that if I did not had the condition, and let's try and do this piece of code without any optional or without any optional binding. So what I would want to do is that if I'm trying to make a check for my stock index above a certain value, I will go forward and say if my stock index is greater than 3000 in the bull market, which I cannot do because it's optional, it's not integer, so I can't really compare it. But I can always force unwrap it, right? So I can go forward, I can say force unwrap it, and I'm gonna execute this code. It's getting executed just fine, and in both places I can see that we are in the bull market. I'm gonna drag this window results pane a bit in so that we can see the values. You can see, okay, it's the same result being published. So why write so many lines of code? The catch is that this stock index is optional. So if line number 23 did not exist, that is recommended on that particular line, and now I try and go and execute the code, it's configured to run automatically. And now my code is just going to crash and burn, and it's a runtime exception or compile time exception as we had talked earlier. The reason is that because I'm trying to use force unwrapping, I'm trying to force unwrap optional which does not have a value, and that's going to result in a runtime error. And if it was your app is going to crash at this point in time. So you do not want that. There's of course a way to do that, which we talked about earlier, which is I can do a nil check on the stock index itself, because stock index is optional, is allowed to have a nil value. So you can go forward and say if stock index not equal to nil, and the force unwrapping of the optional is greater than 1000. Okay, so you can go forward and introduce that check if you want to do that, which is fine and it will work. But that is not considered the Swifty way of doing the things, primarily because Swift is not checking whether you did a little check or not. So it's up to you, and you might forget. So that's not really the recommended way. The recommended way of doing these checks, or making sure that the Swift optional have a value or not, is called optional bindings. And the way it's done is that you go forward and inside the if condition, you define a let. You could have defined a var as well. Okay, perfectly valid. You can go forward and define a var. Okay, as you can see, same result, but it will give you a warning because I'm not really changing the value. So Swift will recommend that it should be a let rather than a var, but var is allowed. Now I'm going to revert it back to let. So you say if let, and you define your variable, and this time I'm saying current index, and I am doing the assignment of stock index. Now this expression, optional binding, is going to return true or false based on the fact whether the stock index had a value or not. And if stock index was nil, this expression is going to return false. So I'm going to drop in the else condition, and which is going to say is that, well, the current stock index needs to be supplied for me to tell you whether we're in the bull or the bear market. I'm not going to assume because it's nil that we are in the bull or the bear market. You need to tell me what the current index is, and then only I can tell you whether we're in the bull or the bear market. But if there's some value specified, then that value is unwrapped from stock index into the current index. And then the current index can go forward and do this standard check. So here I'm checking again for the value greater than 3000. If the value is greater than 3000, we're in the bull market, otherwise we're in the bear market. Simple. This is optional binding, and this is a recommended way of unwrapping optionals in Swift. Next, we're going to move on to the logical operators. And we had trashed logical operators in the past, and that time we actually talked about was, well, there are logical operators present which can provide conditional checks like and, or, and even there is a not operator which is present. But here we'll see how we can use the logical operators with Swift. And as you can see, I can have simple logical operators doing operations like, okay, I'm still checking in my stock market example that if the stock market index is greater than 3000 or not. But I put an additional check saying that, well, yes, for me to be in the bull market, my index has to be above a given value, which is like 3000. Plus, my future or the prospects of how the economy will keep doing have to be right. So that's the additional check we have put in, and we said is okay, we are in the bull market. If the future is bright, when the future bright is here false, and the condition check of standard stock index is 3213, which is greater than 3000. But there's an and check, and it's saying that is future is bright, and the future is bright was false, so we didn't go into the if condition, we went into the else condition. This double and is the logical operator here. You could have used an or operator in certain scenarios where you can say that, okay, for me to be in a bull market, my index has to be in greater than 3000, or I can have a future, bright future. If either is true, then I'm in the bull market. And then this scenario ended up in the bull market. For our example, it makes sense to have an and operator. I'm in the bear market, but if the future turns bright, I will move to the bull market. Next one, we're going to talk about if, else ifs, and lots more conditions. So not always life will be so simple that there's a single if, and if that if is not met, then there's else. A bunch of places you will end up using nested if else conditions. Okay, so and the nested if else conditions are generally avoided because of the presence of the logical operator. Instead of you saying if stock index is greater than 1000, let's just go forward for that example. And then you going forward and saying, okay, if it's greater than 3000, and if its future is bright, then we are in the bull market. Otherwise, we are in the bear market. Can be done this way, like you say, we get the same results back. Okay, so we are still in the bull market, and if I go forward and change the index here to something like 2789, future is still bright, so we are still in the bull market, in the bull market. But here the conditions are a bit off because it was 2789, so we are both going in the else blocks, and we are in the bear market. Same stuff, but just more verbose, and then you would see that I had to copy the else block twice, which is, of course, not a desired result from maintenance perspective, and that's why the logical operators exist. Moving on, there can be conditions where life is not like I was talking about, not simple if else. There would be if X is true, then I'm going to do something. If Y is true, I'm going to do something totally different. If Z is true, then I'm going to do something totally else. So there are a lot of conditional scenarios that are playing for me. And here's what we're going to go forward with. We're going to list down the language that you're learning, and based upon the course name, we're going to tell you that, okay, well, this is the language that you are actually focused on right now. And here we go in with the course name as Swift. So we go in and do condition checks that you're learning C++, Java, Python, Kotlin, Swift, or some other unknown language. And for example, I can say Swifty, and then it will not match anything. And since it will not match anything, then it will go forward and say that, okay, well, I don't know what language you are learning. Let me again expand that results pane so you can see the values. And you can see that, okay, I'm learning a unknown language. Now, of course, I can go forward and change the values, and you will see that different if conditions can be hit. And once the if condition is hit, this whole block is done because the if condition matter is not going to go forward with else if. But the way the block transfers this is that if the first condition is not met, here, if C++ is not met, then it's going to go forward and look at Java. Then it's going to go forward and look at Python. And when the condition is met, the rest of the block is going to be skipped. Now, you will require this in some places, but that's if there are a lot of conditions that you need to check, and if one of them matches and you need to do something unique, then if, else if blocks are generally not recommended. What recommended here are the switch statements. And those are the ones which we are going to see next.